All right, let's take a look at another example. So in this case, we've got this butane, and then we added a component to it, right? So we want to go ahead and ask the first question is, did the number of carbons change? 1, 2, 3, 4. 1, 2, 3, 4. So the first answer there is no. So that probably means we didn't do any kind of acetylide addition or oxidative cleavage, although we might have. Let's go ahead and check out the next question is, did the functional groups change? Obviously, the answer here is yes. In this case, we went from an alkane all the way to a ketone. And so this will give us some hints as what we can do. If we think about alkanes, remember there's only one thing we've learned how to do with alkanes, and that's Br2HV. So you can automatically just put that as the first step. And then we think about the other step, the ketones. How do we get to ketones? So there's at least one way we've learned how to get ketones. One is oxidative cleavage. And then the other way would be to take an alkyne, add some sulfuric acid and water to it with a mercury sulfate catalyst, and then it'll go through keto-enol tautomerization to get to this component right here. So I'm going to go ahead and choose to look at this. You probably could do it the other way. Maybe you want to pause the video and figure out how to get it from the other way. So if we think our last step here is the addition of this ketone, right? We could have here our H2SO4 in water, and then our mercury acetate. And if we think about the alkyne it can come from, one option would be to pick this right here. And again, we still have 1, 2, 3, 4 carbons. So it could add on carbon 2 or 3. Either one will give us the same product. And then we think, all right, we've got this alkyne. What's one way we could have made this alkyne? Well, we could have made it from 2 bromines, perhaps. How are we going to get 2 bromines in here? Well, the main way we learned how to do this is to add Br2 across a double bond. And then finally, we can connect these two with some kind of non-bulky base, right? There are, of course, other pathways to do this. So at the end of all these synthesis questions, there are multiple correct answers. The kind of better step will obviously be the one that is less steps, uses less harsh conditions, uses less pollutants, all those kind of green chemistry. But for our purposes, as long as you get to the end, you're good to go. And really the key here is to just practice. It's the only way to kind of get this stuff down. There's no 100% method that will lead you to the right answer every single time. It just takes some practice and experience.